Good day everyone, especially to our professor, Ma'am Faisa P. Kali. So this is the final oral recitation that we have in MAT051. So I am going to present to you my presentation about my activity. So this is Najib Hassan, so let's start. So the problem that we have is find the volume of the solid generated by revolving the region between the curves y is equals to x squared plus 1 and y is equals to negative x plus 3. So the we have the two given, which is ito. So first is we are going to find the vertex of this equation. So to find the vertex, let's solve for x squared. So we find that x squared is equals to 0. Then x is equals to 0. Then after that, we are going to substitute the value of x to this equation. So that we can find that y is equals to 0 squared plus 1 would be 1. So therefore, we conclude that the vertex of this equation would be 0 and 1. So we can assure the plot we can assure to plot this graph, or we can assure to plot this equation. So we are going to let x values so that we can get 5, 1, 2, and 5. So negative 2, we are going to substitute this to x squared plus 1 so that we can have 5 and zeros, and this 0 we are going to substitute it to this x squared plus 1 would be 1, and also 1 would be x squared plus 1 would be 1 squared plus 1 would be 2, and then 2 squared plus 1 would be 5. To start, since the revolution is between the curves y is equals to x squared plus 1 and y is equals to negative x plus 3. So we use shell method to find the volume of the solid S for x is any element of interval negative 2 and 1. So in this problem, we are going to apply the shell method in order to get the volume of the solid. So we have the volume of S would be is equals to pi integration of f of x squared minus g of x squared dx. So this is the formula that we are going to follow to solve this problem. So we have volume of S is equals to the pi integration of negative x plus 3 raised to 2 minus x squared plus 1 raised to 2 dx. So remember, we have the upper limit and the lower limit, and the upper limit to this problem. So the value of the lower limit is negative 2 and the value of our upper limit is 1. So after that is we have the volume of S is equals to pi integration of x squared minus 6x plus 9 minus x squared minus 2x squared minus 1 dx. So we have x squared minus 6x plus 9 because we are going to simplify this negative x plus 3 raised to 2 so that we can have the answer of this. And we have x cubed x raised to 4 minus 2x squared minus 1. We have this result because we simplify this x squared plus 1 raised to 2. So after that is we can get this. Then we have the volume of S is equals to pi integration of negative x raised to 4 minus x raised to 2 minus 6x plus 8 dx. So we simplify this expression in the inside, so we can get this. And after that is we are going to apply the power rule of integration to this equation. So we have the negative x raised to 4, negative x raised to 2, minus 6x plus 8 is we can calculate the x raised to 5 min over 5 minus x raised to 3 over 3 minus 6x squared over 2 plus 8x. So we can have after after applying the power rule of integration, we have the volume of S is equals to pi times negative x raised to 5 over 5 minus x raised to 3 over 3 minus 6x raised to 2 over 2 plus 8x. We have the denominator of 5 because we add to the exponent 4 so that we can have 5. So after adding 1 to this 4 is we are going to copy the exponent and simply we are going to transfer or we are going to copy the exponent to become denominator and also to this x raised to 2. So we are going to add, we are just going to add positive 1 so we can have x raised to 3 and after that is we are going to copy the exponent and put it to denominator. And then x 6x is magiging 6x raised to 2. And the exponent is 2 so that we can have the denominator of 2. And we have 8x simply because the derivative of x is simply 8x. So after that is we are going to evaluate the upper limit and the lower limit of the integration. So we are going to apply the previous knowledge that we have learned in this subject. So the next is we have the volume of S is equals to pi times negative 1 raised to 5 over 5 minus 1 raised to 3 over 3 minus 6 times 1 raised to 2 over 2 plus 8 times 1. So we we evaluate the integration. So we are going to evaluate the integration, which is the upper limit that we have. So the value of our upper limit or the value of the b is 1. So next is the value of our um, upper limit. So upper limit is a. So the value of our a is negative 2. So we are going to evaluate this to this expression so that we can have this. So we have negative 2 raised to 5 over 5 minus negative 2 raised to 3 over 3 minus 6 times negative 2 over 2 plus 8 minus 2. Okay? So next is a volume of S is equals to pi times 1 over 5 minus 1 over 3 minus 3 plus 8. So we have this equation. So next is negative negative 32 over 5 minus negative 8 over 3 minus 12 minus 16. We have um, we have this equation because it came from to the simplification of this expression here. So next is we are going to simplify this expression or this equation in the inside so that we can have 3 minus 5 minus 45 plus 120. So the denominator is 3 times 5 would be 15. And also this, we have 96 plus 40 minus 180 minus 240 over 15. So we have the similar fraction because the denominator is same. So next is we have the volume of S is equals to pi times 67 over 15 minus negative 284 over 15 is so we can have the calculation of pi 300 times 351 over 15. So the final answer for this problem that we have calculated is 117 over 3 pi. So that's all. I hope you like it.